surname because he hasn't taught me how to say it yet. So Dasith is a distributed systems and cloud architect at Telstra Purple. His talk is all about standing on the shoulders of giants for distributed systems. And I love that quote because it's from Isaac Newton, who was talking about he was successful because he stood on the shoulders of Galileo and Copernicus. I think, Dasith, you're standing on who? Google and Netflix or somebody like that? Anyway, I'll let you explain. So thanks a lot, Dasith.
Thank you. So I hope everyone can hear me well. I'll start sharing my screen. And good afternoon. Welcome to Building Distributed Systems on the Shoulders of Giants. As Sol said, I've got a pretty long surname. Her name is Dasith Vijayasrivardhana. I'm a consultant working for a company called Telstra Purple. Not so long ago, we used to be called Ready Faisal. And I've been helping teams build distributed systems for a while now, and I've got scars to show. And one thing I've realized working with many teams is that developers tend to approach a problem of building distributed systems very much in the same vein they would in-process system. And while our modern high-level languages and frameworks allow us to do this, we really do need to think about the network layer concerns and what happens underneath when we make a network call. And I've seen developers get into the trap of abstracting too much and then realizing the distributed problems occurring and in production. So this talk targets teams who are going in that transition from, let's say, a monolith to microservices type architecture, any distributed system design. The agenda for today, I want to talk about those unique challenges that make distributed system development harder. I've got a curated list of technologies, a good cross-section that I want to go through, and these are some of the products from our giants we want to stand on top of. And at the end, we'll do a quick recap and take some conclusions out of this. So what are these issues of distributed systems or challenges that make it very hard for a developer? Before we go there, we'll look at a simple service in a in-process system. So nothing fancy. We've got an instance of a service and we call a method on it and get a result back. It's running on a single process. Therefore, all the objects are next to each other in the same process. You call something, get the result back immediately. There's no intermittent issue or availability issues accessing an object. This becomes a bit of an issue when you have your service now deployed in a different node. You first need to locate the said service through a logical address, then call a method on that proxy. Here, what the language, your high-level language is doing is serializing, sending the message or the wire, getting it back, deserializing and presenting to you. Now, this is the point where developers think, oh, well, it looks like very, very similar to what I was doing before, so I can just do the same things I did before. But what they don't realize is there's a network in between your calls, between those objects, and the network consists of many network appliances, and this is the reality we have to deal with. There's intermittent network issues because these network components can have reliability issues or intermittent issues. And when you're emulating a network in your local host in your developer machine, it's very easy to assume that the network is going to be reliable. Latency and bandwidth are not going to be problems. And because it's a private environment, you don't really think about security. You think, well, when you deploy it, the admin will take care of it. And these are all false assumptions. And the other thing not many developers or developers new to distributed systems think about is what happens when they go from those 5 or 10 services into 50 or 100. You now need to deal with things like service discovery, load balancing. You need to think about what happens when a downstream service fails. How do you recover from it? Are there any intelligent ways of handling it rather than throwing an error upstream? Security is another big thing. You want your applications to communicate in a secure way, your distributed pieces to communicate in a secure way in any environment. And telemetry, if you've got good telemetry about how your distributed pieces are communicating, this can feed into your business decisions and even things like prioritizing your backlog. So generally, this is the point I really have a critical discussion with the team, have a sit down, make informed decisions about what they want to do in terms of distributing the object design. Do we really need the advantage of a distributed system? Do they outweigh the complexities? And if you still want to go down the path of a distributed design and you've made the informed decision, this is where we can look at some of the technologies from technology giants and see how we can leverage them. So like I alluded to before, I've got a few technologies here. The two main areas that I want to look at is platforms and runtime. So everyone loves Kubernetes, so we've got distributed application runtime, Istio service mesh, and Knative, all of those things that are more Kubernetes focused. Then we've got the odd one out, which is Azure Service Fabric, which solves similar problems as Kubernetes does. And the reason why I curated these technologies is they've got minimum vendor lock-in. You can run them anywhere, any cloud, any vendor. They're cloud scale or hyperscale, and they're proven technologies. Straight off the bat, I want to talk about Azure Service Fabric first, because it's the lowest level abstraction of a distributed system that I can think of from these technologies. And it's a platform that manages the lifecycle of the pieces that make up your distributed system. It's a fully decentralized platform to orchestrate your microservices, and it's got full support for containers, just like Kubernetes. But unlike Kubernetes, it's got support for executables as well. And it's got a Service Fabric programming model on top of its base offering. And it's so powerful that Microsoft uses it to power things like Sky for Business, Azure Event Hubs, Cosmos DB, and Cortana. It's so powerful, in fact, Microsoft uses it to host and orchestrate Azure Kubernetes service in Azure. So this is an overview of the platform as a whole. You've got that edge where you've got the developer machine, Azure on-premise or other cloud, and you've got this distributed runtime that runs on top of that and manages and scales your applications in the cluster nodes. And in the middle, you have this set of programming models that you can use to leverage the capabilities of the platform, things like storage, reliable persistence, partitioning, availability, and scalability. Like I said before, it can run on cloud, on-premise, or developer machine, and it can run it there, run all those environments in a very similar way. Why is this important to you as a developer? Because you can host a cluster in your development machine, take a node offline, take an application or a service offline, and see how your application behaves, your system behaves. And this empowers you as a developer to make decisions based on real life scenarios of how things would pan out in production. And again, as a developer, you've got these programming models to build on top of things like reliable services with both state and stateless options. And if you are into the actor model programming model, you've got virtual actors here too with persisted state options. Guest executables are another programming model in Azure Service Fabric. So you can take any compiled workload, maybe a legacy application even, and let the platform orchestrate that for you. Just like Kubernetes, we've got support for container orchestration, and if you've got ASP.NET Core application, tighter integration with the platform as well. So let's look at an example of an actor in C#. We've got an interface with one method, nothing fancy here. We've got an implementation of that interface. See how at the top we've got an attribute indicating to the platform about the persistent level required. And to invoke this actor from another service or a client, we simply create a proxy using an ID. And this ID can be something that makes sense to you in your domain, like a username or a custom ID. And Then we have the Fabric URI, which has the application name and the actor name. And when you instantiate the proxy this way, the platform creates the actor if that actor doesn't exist with that ID. But if that actor already exists, it simply connects to the existing instance. So all of that's taken care of by the platform. And what this gives you is service discovery and routing, availability, reliability. And if it's a service that you're invocating, you get order scaling as well. All of this given to you by the Service Fabric platform. But what if you've got a team that want to use many languages, and you've got a rich culture of using open source technologies, libraries, basically a polyglot team. And Service Fabric, if it feels like too tight in what it prescribes, maybe Dapr is a way to go. And Dapr really solves this problem by being a fully open source runtime for developers to make it easier to develop microservices. You can use it to build event-driven, stateless, and stateful applications. It's got full first-class support for Kubernetes, and it gives you a programming model on top of the edge infrastructure. So this is an overview of the Dapr runtime. As you can see, it can run on top of Kubernetes or in a self-hosted mode. And on top of that, you've got these building blocks you can use to build your microservices. And these building blocks are exposed through a portable HTTP or gRPC API, and that's why it supports any of these languages and frameworks. If there's a new language today, Dapr will support it as long as it can talk HTTP and gRPC. And I guess the leading point for going something like Dapr is this building blocks that they provide. This is an abstraction of features that you can use to build your services on top of. We've got things like service discovery, state management, pub sub actors. And when you develop on top of these building blocks, you're pretty much building on top of an abstraction, and I'll show you why that's important. I'll take this example of a building block, and Dapr has a thing called a component that is a further abstraction, and you've got multiple components that make up a building block. For example, the actor model building block, you've got the pub sub component and the state component making up the actor model building block. And if you're using the actor model building block to develop your microservice, at the deploy time, you can select which component implementation you want to use for your microservice. For example, if you want to use Redis streams as your pub sub component for the actor model building block, you do that through a service configuration which indicates, in this case to Kubernetes, that you want to use the pub sub Redis implementation. And this is very powerful because then you're building a microservice against abstract building block model, and the actual component implementation you can decide at the time of deployment. Similarly, if you've got your favorite library or third-party open source tool that doesn't still have an implementation for a Dapr component, all the Dapr components have a public interface. You can implement that, push that to the community repository in Dapr and make that available if you want to do that. And all of these building blocks, or at least most of these building blocks, have endpoints which are convention-based. And we'll look at how we can use the service-to-service invocation in an example. So imagine this is a node service that you're developing. It's got a simple endpoint, returns a status, and we want to host this service through Dapr. In a self-hosted mode, you use the Dapr runtime. And when you run it using Dapr, Dapr spins up a sidecar process. And this sidecar process basically routes all the network traffic from and to that node application. And if we want to invoke that node application, we now invoke the Dapr service invocation endpoint. And this is how we do it. As you can see, we've got the application name and the method name. And when we invoke it, Dapr fetches requests, routes it to the right service, gets the result back, and forwards it through to the caller. This is the same thing happening in a Python app that's trying to invoke that Node.js app we developed before. You've got that same URL with the convention, and underneath, Dapr is doing service discovery and routing, mutual TLS, that's security between the two service calls, and the retry logic if required. It gives us tracing as well. And there's talk about things like circuit breakers coming in the future. So in that self-hosted mode, I spoke about how Dapr uses this sidecar process. This is a representation of that. The sidecar process has an API that exposes all the Dapr building blocks to your application, as well as doing all the routing. And when it's in a Kubernetes pod, it does similar things, but it uses a sidecar container. And for anyone who's a astute observer, they might already be familiar with this with a service mesh. But what the service mesh doesn't give you is these rich building blocks or abstractions to build your program microservice on top of. But on top of just the network layer handling, Dapr provides these as well. So this is how Dapr does that in a Kubernetes cluster. We've got the control plane components to pretty much orchestrate those sidecar containers, inject them, and make sure they can talk to each other. This is a detailed view of what's happening in Kubernetes using Dapr. As you can see, we've got all the component implementations, all those third-party open source tools that you love. Then you've got the control plane Dapr components, and finally you've got these pod running your containerized workload and Dapr running as a sidecar, exposing your building blocks, and also doing the network routing. And this is a good segue actually for use cases where you already have a container. So the team might be already producing containers, and you might have a few. And this is where service mesh might be a better choice for you, or a easier thing to migrate to. Service mesh, for anyone who doesn't know, is a way to control how different parts of your application connect to each other. You can secure the communication and observe how the pieces of your distributed system communicate and base decisions on those behaviors. And the reason why we need one is when we go to hundreds of microservices, it becomes very time consuming to manually connect them up and have that logic and scale it. And Istio is a market lead in this space, and it does the service mesh in Kubernetes through a control plane component, which injects this sidecar proxies, Envoy proxy, and does similar things to what Dapr does, but this handles all the network layer, and it doesn't give you the same programming model or a rich building block to build your microservice on top of. So this is agnostic about how you develop your application. This just handles the network layer. And the elevator pitch, of course, is that you can focus on the business domain rather than how to connect your microservices, and get behavioral insights about how your microservices are used. As a developer, if you have the knowledge that your service is going to be deployed on top of a service mesh, you can use logical naming conventions to find your service or your distributed piece. You can invoke a method on it, and you get dynamic service discovery, load balancing, TLS termination, and even things like circuit breakers, which are going a step above just a network layer concern. And the next question is, what if you don't even want to install and manage Kubernetes, or install Istio and configure that? This is where something like Knative comes to your rescue. If your development team doesn't have a lot of DevOps experience around Kubernetes, because it's very advanced, and Istio, managing a service mesh, network configurations, etc., Knative can really help your developers be more productive. It solves the boring but difficult part of deploying and managing those cloud-native services. It does this through a set of middleware components that extend Kubernetes. And for a development manager or someone who's looking at this from a business perspective, The elevator pitch is that you can build modern source-centric and container-based applications very fast that can run anywhere on-premise, in the cloud, or even in a third-party data center, anywhere Kubernetes runs. From a developer perspective, you get the same experience that you've always had with things like GitOps or Docker Ops. You don't have to go into details about how Kubernetes, network engineering, etc. work. And let's take an example of how you would quickly get one of your containers into Knative. And this is a very simple example. We've got a configuration where we've defined some metadata about the service, the name, and the namespace. We've got the container image in the repository, and we then use the Kubernetes CLI, apply that configuration, and Knative at this point does all the network engineering, everything required, like blue-green deployments, deploys the application, creates a revision, and we can then hit this convention-based endpoint with service name, the namespace, and the cluster name, and get a result back. What's happening underneath here is Knative uses a service mesh to do routing, load balancing, TLS termination, pretty much things that we got out of Istio as a service mesh too. It does things like blue-green deployments and smart scaling. So you can let Knative route different percentages of your traffic to different revisions of your app, and do things like scale to zero, where if you've got a few services and one service is not being used at all, but the others are getting high amounts of traffic, the platform is very smart to make sure that you take the resources off away from that container that's not being used and make those available for the other containers. So I know I sped through most of this. We don't have a lot of time. How do you pick a winner? I'll start with Istio here because it's the easiest one to, I guess, compare to. If you've already got container workloads, this is a good solution for teams that don't want to go down to the network layer or think about solving those problems. It doesn't enforce the programming model, and this is where Dapr comes into play. So think of Dapr as what a service mesh provides, plus it provides a programming model as well with building blocks. And it's still new but growing fast. It's extensible, has full support for Kubernetes, and it's very powerful in the sense that you can leverage any open source library or tool that you like, and any programming language as well. And on the other side, you've got Knative, which allows you developers to produce containerized workloads and not worry about how they're all connected and how they run. And this makes developers really productive. And this might be a good option if you've got a development team who are very good at software development but don't have that DevOps experience yet. And Service Fabric being the odd one out here, it's a platform to orchestrate your microservices, either containers or executables. It's mature and trusted, and you've got support for Windows or Linux clusters. But be aware, while it's very powerful and very low level in terms of abstracting your distributed system, it doesn't have a big community or a lot of support. Microsoft uses it internally in a certain way, and as long as you're using it the same way, you're good. But as soon as you deviate and try to do something different, you might find that getting support for it is kind of difficult. But your mileage may vary. So what's the takeaway message from this quick presentation is to stand on the shoulders of giants. Don't try to reinvent the wheel. We know technology giants like Microsoft, Google, Netflix, they've got the skills, the resources, and the knowledge to develop solutions to solve the problems at the network layer well. And we know they will follow the best practices if you take a long period of time. And if you try to develop your own runtimes or your frameworks or libraries to do things yourself, the risk is you might not follow a best practice. You might not have the resources to maintain that in the long term. So don't spend time solving those difficult and boring bits like engineering, network engineering. Focus on solving business problems. That's what you're good at. That's what the business is paying you for, and that's what should be your focus. So I'm happy to take any questions at this point. Um, uh, you've got my Twitter here as well if you want to have a bigger discussion. I'm going through a similar learning journey, but yeah, I'm happy to take any questions if anyone has them.
Okay, great. Thanks a lot, Tassif.
No worries.
That's a really, really great kind of cook's tour through these distributed systems frameworks, and they're all relatively new, which is interesting. So we're seeing this kind of Cambrian explosion of new frameworks. Dapr, I think, is probably the newest one. It's only about 12 months since it was announced. Have you seen it being used anywhere for real yet? Do we have lessons from the field?
So not in a production environment. That's a good point. I was just looking at a Microsoft presentation about it, and it's already got more momentum than Knative and Kubernetes did at the start. So that's a good thing. They've got, I guess, developer engagement, and the number of component implementations are growing really fast as well. So I think we've got developer buy-in. The fact that it can support many languages and frameworks means that developers don't feel their hands are tied when they go down the path of Dapr. But like you said, it's very new. So I don't have any production experience with it. I'm happy to hear about if anyone's got production experience, but I've got a few projects coming in the future that I might be keen on using Dapr with.
Yeah, it'll be interesting. So we've got a question from Miguel. What is the time to start to implement a Kubernetes and Istio architecture to start to develop microservices?
So I'll take that in context of what I spoke about Istio in my slide deck. In my opinion, compared to something like Dapr, where it gives you this programming model to build on top of, if you don't want that, and if you are happy to produce containerized workloads already, or if you already have containerized workloads, then you can go down the path of Istio, because you're only really after solving the network layer problems. Whereas if you're going down the path of a greenfield project, even though Dapr is not only for greenfield projects, if you're doing something like a new project and you can leverage those building blocks to accelerate your development, then Dapr might be a better choice. So in the context of my slide deck, that's pretty much how I would answer the question.
Right. And any idea about timeframes? What's the learning curve, I guess, for these things?
So Dapr, the learning curve isn't that great. You can probably start off with a Hello World application and get a decent complexity application going in a couple of weeks. It's very easy to learn in terms of Dapr. But when it comes to Istio and Kubernetes, it's really how long is a piece of string. Kubernetes is very complicated, and this is where, if you're going down that path, you need DevOps experience, and that's why many teams are now going with things like Knative, because you don't get a lot of DevOps experienced people these days with many teams. So I can't give you a direct answer, but all I can tell you is it is complicated when you go down the route of Kubernetes and you're doing custom configurations, etc.
Yeah, I think that's true. And related to Dapr, I think we've got, so with Dapr, this is from WW, does that mean it will require code changes for existing code base that's already running in a container?
Not really. So you can take it as a piecemeal approach. And there's a good example on the Dapr repo, and there's a few presentations by Microsoft talking about this exact topic. You don't have to change your code base straight away. You can start introducing pieces of those building blocks, and eventually you'll see that it takes over your system, but you can still take your existing microservices and use something like Dapr, and you use the building blocks as you go, and then refactor things as you find more use cases for them.
Okay, great. All right, thanks a lot, Dasith. That was
All
a
right.
really good presentation. Thanks for your time.
Thanks all.
And we'll see you later.